Hey friends, we're going to deal with 2-2. That doesn't mean anything. 2-2. It sounds funny. All right. Power functions and modeling. We're going to talk about some of the power functions that you got to see when we did some activities in class here, dealing with those uh, families of functions, things going on. But most importantly, we have k, right? That was the a value before, so don't let that throw you off. Just keep in mind where it's at and what we're asking for. A is the power. Based on its location as well. The only weird thing I want to try and point out as we look at these, remember this was the first power. So it has a power, all those things happen. We can have negative powers. We can have fractions for powers. There's a bell going off. Remember the cube root, if my pen would work here, is x to the 1/3 power. So we can deal with all those things as well. So as we move through some of those, that's not a big deal. All right, done with that paper, done with that one. All right, let's see what we're doing. We're going to take a look at some of these graphs, things we may or may not be familiar with. So we just said that this could be x to the 1/3 power. So my question to you as we take a look at it is, does that appear to be even, odd, or neither? Remember, odd was the thing that was kind of rotational here. So it definitely appears to be odd, because out of my list of questions, I want to make sure I pointed that out first. It keeps along those lines that we're talking about, kind of that 3, we see that going on. So it looks odd, right? As we look at 1/x², right? This could be x to the -2nd power. So that would also give us the appearance of being even as we fold the paper left to right. Odd was rotational. So a nice comparison of those two side by side. Let's take a look at all the kind of basic questions we've been through a couple of times now, and I'll try and fill in some answers as we go. I might try and shorthand this just to keep your video a little bit shorter. Domain, all right, my left to right, that's all real numbers. Remember, we'd use negative infinity to infinity. The range, it's going to continue up and down. So that's, again, all real numbers. Is it continuous? Well, I don't see any breaks or jumps in it. So I'm going to go with yes, right? We could say that it is continuous. Increasing or decreasing intervals. Here's where we kind of trace the whole thing. And my pen is going up, 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 up the whole time. So it's increasing the whole time. So as an interval, I would say from negative infinity to infinity. And we don't count those because we have that going on. Is it symmetric? Is it symmetric? Right. So I guess here's where we could have said that it's odd, which means it is symmetric based on the origin, or 0, 0. Is it bounded? Well, if we said the range is going to be all real numbers, then we're going to have to say no. All right, definitely not, because it will continue up and down. It looks like it's going to go a little bit slower as we deal with that. Do we have any local extreme, right? So it's a local max or min. We're going to go with no on that one, because we don't have any turning points, so we can't really do anything with it. We said that it is continuous, so are there any asymptotes? Nope. And what's the end behavior? The end behavior. So just to review that limit notation, as x approaches negative infinity, so that's going left. The function, all right, is going to approach negative infinity. And as the function value goes to the right, positive infinity, the function goes to infinity. So ideally, right, if we're shorthanding everything, we would say the end behavior is down, up, right, down, up. No big deal, don't have to deal with it. All right, let's list all that again. For an even function over here, right, we had translated this one, -2 makes it 1/x to the 2nd power. So domain, well, it can't be 0, right? That's going to be a vertical asymptote. So we can kind of jump around here if we wanted to. We have x equals 0. So let's jump the whole way back. So this one, we're going to have to write negative infinity to 0, union 0 to infinity. That's my left to right as I look at it, left to right, and what's happening. When I look at the range, it looks like we're going to go from 0. It looks like we have a horizontal asymptote. So we're going to go from 0, where we don't touch it, the whole way up to infinity. So that works out for those. Is it continuous? No, it's definitely not, right? So where is it discontinuous, right? X cannot be 0. All right, so we identified that through the domain, but if the question skipped domain and range, we'd have to be able to identify it some other way, increasing or decreasing. So again, remember you want to trace right over top of your function. So right now it's increasing the whole time. So from negative infinity, I always want to work left to right, negative infinity until 0, but I don't actually count 0. That's going to be increasing. And then my decreasing, so decreasing is going to be from 0 to infinity. As we take a look at those, remember it's going to keep getting closer and closer, but I'm never actually going to reach 0. Is it symmetric? Yeah, we already said even. All right, remember even is something that we can fold over the y-axis. Right? We could also plug in, I should have said that the first one. If I did 1 over negative x squared, this would be another test. But I get 1 over x squared, which is the original. So here we give you a picture. I think you guys are pretty good with that. Is it bounded? So only below, right? Because we have this horizontal asymptote at y equals 0. So I think that's my next question anyway. All right, oh, so let's add that one in there as well, y equals 0. Any local extremas? Nope, no turning points, right? It's always increasing or always decreasing in those sections, and then it's discontinuous. So end behavior. All right, as we go to negative infinity, code for left, the function goes to 0. And as we go to the right, the function goes to 0. All right, not too bad. All right, third one over here, I have filled out for us. Where is it? There it is, this little stinker. Square root function, here we go. So domain, we're starting off at 0, 0. That counts. That's where this one's a little bit different. We've seen that before. So notice I have a bracket on there. Same thing for the range. It is continuous from 0 to infinity, right? It just plays along with that domain, right? It's not continuous. Before that, we don't take square root to zeros. It is not symmetric. Doesn't matter if I fold it up and down, left and right, or spin it around. It is not symmetric. It's bounded below, but not above, right? I can put this horizontal line below. It'll never cross over it unless it's translated. So this is based on its parent. We do finally have a local minimum, right? That would be a local extrema in some other books. No horizontal asymptotes, no vertical asymptotes, right? Those are lines that it's not going to touch. The only thing that we have here is domain restrictions, but that doesn't make a vertical or horizontal line on here. The end behavior, as we go to the right, it's going to go to infinity. So no big deal there. Square root function, we've seen that one just a couple times before. Let me see what we got next. Here we go. So not too much to note there. Oh my goodness, just scroll page, would you? Here we go, that's better. Use the mouse, pen, the fingers. All right, monomials. You guys know what a monomial is. For some reason, we just want to point that out. So notice that I have some sort of function going on here. This is like saying 3x squared. All right, you guys know that as a monomial. Let's not try and make it very confusing. All right, 3 we used as an a value before. Right, now we're saying it's a k value. And if it's 3, we said that's a vertical stretch of 3 before. That made whatever function it is taller in some way, shape, or form. If I used 1/3, it was going to make it shorter, which also made it wider. And then we're also talking about having 1/3, which would make it, or we talked about having negative, which is an x-axis reflection because it's on the outside. So just keep those 3 things in mind. Using n as the power, so n equals 2 for this little example here. And it's a monomial because I don't have plus or minus like 5x and then minus 8, right? So if I had something like this, right, this is a trinomial, just to get to the bare roots there. We just want to make sure everything we're going to deal with right now is monomials and then ask you for some of those details. All right, so we gave you the graph here. We just want to talk about what's going on. So we're going to identify a couple things. We have 2 out in front of it. So you guys know that was the old a value. Remember, we're going to use k right now. So k equals 2, the power equals 3, k equals 2. That's known as a vertical stretch. All right, so we'll give you a quick guess here. Which one has been vertically stretched? Which one's taller than the original? All right, so you said the black one instead of the blue dashed one, right? Blue dash is the parent here. That was going to be super nice to realize in the next one, right? Because we want this one to be the -1. It's x to the 4th, so it looks like x squared, kind of making that parabola shape. It's been vertically compressed. That's why it's so wide, but then it's upside down, x to the 4th power. So here we have k equals -2/3, right? So that's that upside down, right? X-axis reflection, the 2/3 is going to give us a vertical compression, and the power equals 4. Right, so which one's even and which one's odd? Okay, so power of 4. So this guy ended up being even. Power of 3, this guy ended up being odd. And we can start to mix those up just a little bit more as much as we need to. And hopefully that's review. All right, let's get those values one more time. Look at that, we're done with page 2. Let's take a look at the next one here. All right, so it isn't matching. I have them directly above, below those. So it says state the values k and a. They're using a for the power, makes that a little bit shorter. So k is 2, a is -3. Right, so is it even, odd, or instead of saying neither, we're now going to transition to undefined. Okay, but if we said neither before, we're now going to call it undefined. Just continue to build that vocabulary and why it is neither. All right, so as I take a look at this one, obviously from the power is the third power. We're dealing with a negative, which means it's just a reflection of a third power. So we're definitely going to be talking about an odd function here. Now we take a look at the next one. The k value is -0.4. The a value is 1.5. 1.5 seems weird. I don't really know. Like, I can tell from the graph that it's neither, right? I can't reflect it around the y-axis, and I can't spin it around and see it on the other side. So I just want to take you on a little idea here. So 1.5 is actually 1 1/2, which is actually 3/2. And remember, we're talking about the power over the root. And since we're kind of stuck in between, that's why you'll see a neither on this one. And that'll be really important when we look at letter C here, because you can tell from C that it is even. And we want to show you why that is. So K turns out to be -1, right? It's a little bit invisible, but it is -1 right there. The A value is 0.4. All right. 0.4 is a bunch of different things. That's 4/10. We don't write that. That's 2/5. So that's a power of 2, which is why this graph is going to end up being even, right? Even. So we have a little bit of a combination here. So we do have a fifth root, but it leads me to the idea that it should be even. All right. Yeah, I think that's what we have. So we said odd here, we said even here. Right, before we said neither for these, remember we're going to call undefined for when x is less than 0. Just getting a little more technical as we go to deal with it. All right, so identifying the coefficient is k now, power is a, and then just dealing with even, odd, or neither. All right, we get some, excuse me, some homework down below here. We'll work on that in class along with your questions. All right, thanks for watching the video and have a great day.